Hello everyone, welcome to iitiansgateclasses. So guys, just respond, am I audible? Those who are watching this session.
Yes,
Yes,
sir.
Avdesh, it is good evening. Okay, not good morning. So good evening guys. Welcome to IGC. Okay. So guys, in this session we will be discussing briefly about strength of material. Okay, and we'll be seeing the some of the PYQs. Okay, related to topics which we are going to discuss. So currently, guys, admissions are open for GATE 2025 and 2026 in IIT's GATE classes, and we teach for all these branches for aerospace, mechanical, engineering science, production engineering, electronics, electrical, instrumentation, CS, and data science. And these are the courses we offer at IGC: GATE online coaching, target GATE course, GATE online test series, and distance learning program. Now, guys, our next batch, upcoming batch, or you can say it's from Feb 18, and many of you have already enrolled, and those who want to enroll, hurry up. The registration may get closed by Feb 15th. Okay. Now, guys, in today's session, we'll be discussing about strength of materials. Strength of materials. Okay, and in strength of material, specifically about basic elasticity, and in basic elasticity, we'll be discussing about stress. So we'll be saying stress is very important topic in gate mechanical and gate aerospace in from exam point of view also, and stress is also very important topic in your academic if you are working in structural analysis area. Okay, so guys, first, what about basic elasticity? So in basic elasticity, guys, there are many topics, okay, which we study in strength of material. First, we always start with stress, and then we discuss about strain, and then stress strain relationship. Okay, and then many other topics which are related to these three. Along with that, we also study thermal stresses, volumetric strain part. Okay, so all these things we cover in basic elasticity. And from gate perspective, basic elasticity is very important topic. Either it is in gate aerospace, gate mechanical, gate production engineering, gate engineering science paper. Okay, and at least always basic elasticity asked between 2 to 6 marks. Okay, sometime for 2 marks, sometime 4 marks, and in fact, in some of the paper in a gate aerospace and in gate XC, basic elasticity was asked for up to 6 marks. Okay, so guys, if you plot this complete basic elasticity, how things are working, so you know what is the simplest relationship between force and displacement? Can anybody tell the relationship between force and displacement? Can anybody tell what is the relationship between force and displacement in the simplest form? Avdesh, what is the relationship between force and displacement in simplest form? Gopal, Shubham, Nived, Shaurabh, Madan, Sindhuja, Dhananjay, Anand, Adarsh, Avirup. Work done is equal to force into displacement. I am not asking work done. I am asking the relationship between in strength of material between force and displacement. So the force is some k times delta. You guys know this simplest relationship for truss kind of member or spring. Yes or no? So force is directly proportional to what? Delta is what? Displacement. And what is the k? Guys, what is the k? K is stiffness, right? What is
Yeah.
K? K is stiffness, right? Yes, Anand. Okay,
No,
K
sir.
is
Bye.
stiffness. But when you have complicated problems, not like simple truss structure or spring, if you have a three-dimensional structure and when it is subjected to loads, we cannot use directly this relation, right? Yes or no, guys? We cannot use directly force equal to K times displacement. We need to arrive with some complicated approaches. So basic elasticity is one of the approach. Along with, you guys might be knowing, right, numerical methods and all. So you guys might be knowing finite element method, right? FEM approach is very widely used in structural analysis. So what is the fundamental of FEM? Anybody have done FEM course in engineering? Those who are watching session can tell if they have done this FEM course. So what is the fundamental of FEM? The fundamental of FEM is what? Basic elasticity. And in basic elasticity, what? We study all these things. Okay. So what we have to study in basic elasticity, guys? So force is related with displacement, and displacement is related with what? Strain, and strain is related with what? Stress, and stress is related with what? Force. So force and stress is related with what? Equilibrium equation. Okay, and stress and strain relationship is what? The simplest form of stress and strain relationship is what, guys? The simplest form of stress and strain relationship.
The Hooke's
Anybody?
law
What is
from
the it's a Hooke's law,
Hooke's law.
right?
Yeah.
Yeah. For 1D problem, it is Hooke's law. But if it is not one-dimensional problem, then what it is? It is known as consti- constitutive relations or stress-strain relationship. Okay. Now, guys, displacement and strain we all know, right? Strain can be written in terms of displacement, right? You all know epsilon x is dou u by dou x, epsilon y is dou what? Dou v by dou y, and epsilon z is what? Dou w by dou z. What u, v, w, those are displacement field, right? And we know what is the difference between solid and liquid also, right? In case of liquid we use strain rate, right? In case of solid we use strain. Okay. And we already know that relationship between force and displacement is what? K times delta. So this is what the whole, study we do in basic elasticity. Now, guys, in today's session we will discuss briefly about stress. So, guys, what is stress? Can anybody tell? What do you guys mean by stress?
Force acting
Like
on a
any
unit
force
area.
applied in a unit area, eh, force applied anywhere between the areas are like a
Hmm?
surface. Force applied to the surface or unit area.
Okay, that is what you can say. It's like unit. The force per unit area is what? Stress. Okay, but that is what Sam pressure is also, right? Force per unit area. So what is the difference between then force and stress? Hmm?
Sir, stress, like stress can be deformation. It can take the deformation, like pressure can't be deformation. So deformation can't be take place in a pressure.
Pressure will also change volume, na? It's not like that. See, pressure
Yeah,
changes volume, right? So it's not like that. So the difference between
yeah.
stress and pressure is very simple. Both
Sir,
are
the
having
stress is
same
a
unit. Stress is a
the
tensorial
stress is a
quantity.
vector.
not vector. It's a tensorial quantity, Anand. And pressure is what? A scalar quantity. Okay. Now guys, pressure, we all know the how pressure acts, right? Usually. But stress is like, it's an internal resistance provided by what? Strength of the body against applied load is what? Stress. So you guys can see the definition is written. It's a resistance force induced within the body by the strength of the body against applied load is what? Stress. But if you see numerically or physically how it is different, then we can say pressure is a scalar quantity and stress is a tensorial quantity, and we will see what tensorial quantity mean. Okay, so you guys understand the definition of stress? All of you understand? Yes or no? Okay, so guys, there are usually two kind of stresses. One is normal stress. One is what? Normal stress. So normal stress is denoted by sigma. It is also known as direct stress. Okay, and sigma is what? You can say limit delta A tends to 0, delta Pn by delta A. So delta Pn is what? Suppose you are taking a surface on which you want to find stress, and on this surface, at this particular point, there is some force which is acting inclined. Okay, the resultant force on this surface is inclined with some angle theta, right? So there will be two components of that. One is normal component and one will be what? Shearing component. Okay, one will be normal component and one will be shearing component. So this normal component will give you normal stress, or it is also known as direct stress, and shearing stress usually denoted by what? Tau. So what is tau? It is limit delta A tends to 0, delta PS by delta A. Now you guys can see we considered what? A body, a three-dimensional body, and which is subjected to multiple loads like P1, P2, P3 and so on. There we consider this plane NN. Okay, on this plane at this point O, okay, there is some resultant force delta P. Okay, so this delta P is making some angle, okay, with plane theta angle. So that will have two components, one is normal and one is shear. So the shearing component of force will give you shear stress, and normal components will give you normal stress or direct stress. Okay, so this is in general. Now guys, this sigma and tau are what? Greek words. Okay, Greek words, okay, for normal and shear stress. But in actuality, in basic elasticity, what we use for stresses, can anybody tell? Do we use just sigma and tau alone or something extra than that? What we use always, we use something called sigma ij or tau ij. Okay, right? Yes or no? We simply don't use what? Sigma or tau. We use what? Particular notation, sigma ij or tau ij. Okay, what I represent guys here? Anybody? What I represent? The plane on which stress is acting. Okay, what J represent guys? The direction in which stress is acting. Okay, so this is in basic elasticity. Usually we denote by sigma ij and tau ij. Now if I equal to j, what it mean guys? If I equal to j means what? It's a normal stress. Okay. If I not equal to j means what? It's a shear stress. Okay. Clear everyone? What this notation means? So if you guys have any doubt, can quickly ask. Yes, Avdesh, if any doubt, quickly ask. Okay. So guys, now before moving that, we need to prove, right, what? Stress is a tensorial quantity. So how we prove? See, when you see the initially three-dimensional body, we have taken one plane NN through point O. But you can take infinite number of plane, right, through this point O. Yes or no? You guys can see here in this figure. You can see the initially this is your NN plane, right? And what was your resultant force? It was delta P. What was the angle? Theta 1. Now if you change your plane from NN to MM, what is happening, guys? What is happening? Theta is what? Changing or not? Quickly, guys. If you change
Yes, sir.
your plane, reference plane, theta will change, right? So what it mean? If you change your theta or if you change your plane, what will happen? Your delta Pn and delta Ps will change, yes or no? Because delta Pn is nothing but delta P sine theta and delta Ps is nothing but what? Delta P cos theta. Here P is missing, so it is what? Delta P cos theta. Clear? Yes or no, guys? Okay. Now, guys, if you go back and see, if you go back and see your sigma and tau, if you change your plane, delta Pn and delta Ps changes. So that means what? Your sigma and tau will change, right? By changing plane, right? Yes or no, guys?
Yes, sir.
Clear? This point is clear, Anand?
Sir.
Yeah. So that means your stresses depends on the reference plane, right? Okay. So stress require three things. One is what? To define well. The first thing is what? Reference plane. Then what? Second thing, magnitude, and then direction. Clear? So you can see the stress required first reference plane, then magnitude and direction to define. So stress is what? A tensorial quantity of second order. Clear everyone? So it depends magnitude, direction and the plane on which it acts. Everybody it is clear? Why stress is a tensorial quantity? Yes or no? Okay, so now you understand about this. The next part is what? We have already discussed this part, the notation and direction of stresses. So first we already discussed in basic elasticity, your stress is denoted by sigma ij or tau ij, and here I indicates the plane on which stress acts and j indicates the direction in which stress is acting. Okay, so this is what the next part is what? Sign convention. So sign convention. So sign conventions I will just explain by taking a case of two-dimensional stress system. So in 2D stress system, guys, suppose you take XY plane. Okay. This is what? XY plane. Okay. 2D XY plane. So you all know, right? This is what? Z plane, right? If you take perpendicular to this is what? Z. Now in x direction, what is your stress always? Now tell me guys, what will be the plane which is perpendicular to this face? Anybody can tell? If you take some finite thickness, what will be the perpendicular plane in anybody? You can see if I draw 3D. So what is the plane? Anybody? This is your x direction now. This is your z direction, and perpendicular is what? Y direction. So what is this plane? Anybody? This is xz plane, right? So you can see on this face your stress. So what is your plane? Not xz plane. This is what yz plane, guys. This plane is what? Yz plane, right? Yz plane. So what is yz plane? It is known as x plane. So the first I is what? X, and in what direction we are finding it? We are finding in x direction, so it is sigma xx. Now this, on this yz plane, I want to write shear stresses. So how I decide the direction of shear stresses? I decide based on this normal stress. So here you can see normal stress is going in positive x direction, on positive x direction. So the corresponding shear will also, guys, will be in positive x direction, like the positive x direction, not positive, like on in respective positive direction. So what is respective positive direction? It's a y direction. So you can see it will be sigma xy, and then this is positive z direction. So this will be what? This will be sigma x. Okay, now guys, if you take this plane, on this plane, what is normal, guys? Positive x or negative x? What is the normal on this plane? Positive or negative? Gopal?
Negative I.
Negative, right? Anand, negative, right? So that means, and now tell me guys, this it is in negative direction, right? So again, what is plane? It's a yz plane, but x is going in negative. So plane is still x, negative x plane. So I will be x, and direction is also x, right? Now tell me, this sigma xx is tensile stress or compressive stress?
Sir,
It's a
if
tensile,
Tensile
right?
type.
What is
tensile
the
stress,
definition of tensile stress? Yes, mother. See,
force acting normal to the plane, sir.
the always tensile stress means your stress will go away from the section. Okay, it is not about the direction, right? You can see this is what your plane, right? So this stress is going away from plane. Same way, this is what your plane. So on this, it is going away from that. So that means it's a tensile stress. Okay. So this is the tensile stress, though it is going in negative x direction. Now, guys, on this plane, this is the highlighted plane. What will be my corresponding shear stresses? Can anybody tell? It will be sigma xy and sigma xz. But what direction it will be? That is what we are discussing here. Anybody? Okay, let me tell. So see guys, here you can see this your tensile stress sigma xx is going in negative x direction. So my corresponding shear stresses will also go in negative y and negative z direction. Very good, Gopal. So you can see this will be what? Sigma xz, and this will be what? Sigma xy. Clear? So guys, we have just written our stresses on two plane only, but similarly you guys can see, you can write your stresses over all the planes in a three-dimensional body. You guys can see this figure clear, right? If you take your this plane, right? So this surface perpendicular to this is what? Y, right? It is xz plane. So you can see what is your normal stress. The plane is y, the direction is y, so it is sigma yy. Then corresponding shear you guys can see, since it's going in positive direction, so corresponding shears are in positive x direction and positive z direction. If you take bottom, your normal stress is going in downward direction, which is negative y, so the corresponding shear also in negative direction. Everybody, is it clear?
Yes, sir.
Yeah. Okay, now guys, if you look here, I want to write my stresses in a matrix form. Okay, so in matrix form, if you write for three-dimensional stress system, how many total stresses are there? Anybody can tell? On this 9, right? So your sigma ij is what? It is sigma xx, then sigma xy, and then sigma xz. Then it is sigma, or sorry, not, I can write tau or sigma. So sigma yx, this is sigma yy, and then sigma yz. Then last row will be what? Sigma zx, sigma zy, and then sigma zz. Clear everyone?
Yes,
So
ma'am.
this is
Yes, sir.
stress matrix. Now guys, in this stress matrix, what is this sigma xy? It is what? Normal stress or shear stress?
Sir, normal stress.
Normal stress, right? It's a normal stress. Normal stress, is it, Anand? Is it normal stress?
Sir, it has to be shear stress. Normal stress means that should come
Exactly. Why
entirely.
shear stress? Why shear is why shear stress? Because you can see here I is not equal to J. So in basic elasticity, we don't bother. We are writing with sigma or tau. What is important? I is not equal to J. That means it's a shear stress. Now I am writing one thing. What is tau ZZ? It's a normal or shear stress? Dhananjay, it's a normal stress. Why it is a normal stress? Because here I can see I is
E is
equal
equal
to
to
J. J. Exactly. So it's a normal stress. Okay. So guys, this is how we write three-dimensional stress system. Now comes to next. Usually in your gate exam or in your academy, we usually discuss about 2D stress system. 2D stress system, right? So for 2D, you can see usually we write 2D stress system in XY plane. So you know already, guys, on this plane, the normal is X. So what is your stress? Sigma XX. Now, guys, corresponding shear will be in what? Positive y direction, right? So you can see it is sigma xy. Now guys, if you see here on this plane, your stress is what? Sigma yy. it is going in positive y direction, so the corresponding shear is going in positive x direction, which is what? Sigma yx. Same way guys, on this plane, which is what? Plus y or minus y? Anybody? The bottom plane is what? Plus y or minus y?
Minus y.
Minus y, right? So the corresponding shear is in what? It is in negative
Negative
y
direction
direction,
of x.
negative x direction, right? Now guys, the last plane, which is what? This plane, right? Now what it is? Negative x or positive x? It's a negative x, right? So corresponding shear is in what? Negative y direction. So you guys understood, right? This stress system, how we draw in basic elasticity. Clear everyone? Yes or no? We can do a poll quickly.
Yes, sir.
I think. Okay, fine. Yes. So now guys, if you write in matrix form, what is your two-dimensional stress system? If you write in matrix form, it is sigma ij will be what? It is sigma xx, then sigma xy, and then sigma yx, sigma yy. Everybody clear about this matrix? Yes or no? Now you guys know there is something called complementary nature of shear stresses. So can anybody tell what is complementary nature of shear stresses? Yes or no, guys? What is complementary nature of shear stresses? Deepak, what is complementary nature of shear stresses? Saurabh, Nived, Vinayak, Abhiru, Dhananjay, what is complementary nature of shear stresses? What opposite is stress? See, from complementary nature of shear stresses, what we know, on two perpendicular plane, on these two perpendicular plane, your shear stresses will be of what? Same magnitude. Means your this sigma yx will be equal to what? This sigma xy. So from complementary nature of shear stresses, that also we prove guys, while deriving equilibrium equation, we prove sigma xy is always equal to what? Sigma yx. Same way, your sigma xz is always equal to what? Sigma zx, and your sigma yz is equal to always what? Sigma zy. So this is known as what? Complementary nature of shear stresses. So on two perpendicular plane in a body at any point, your shear stresses are of complementary nature. Okay, so their magnitude will be same. Either they will oppose, they will approach each other, or they will go away from each other. You can see on this and this plane, you can see this is going up and this is going in this direction, so they are going away from each other. You can see here they are coming together each other, or they are approaching each other. Clear? Now guys, tell me, once you know sigma xy equal to sigma yx, how many independent stresses here in this 2D stress system? How many independent stresses?
The normal stress. Sigma
Independent.
xx, sigma
How many independent are there?
3.
Like total four. Out of four, how many independent? Two, two are independent. Huh? Total, how many independent? Three. What 3 means? There are 2 normal stresses and 1 is shear stress. Clear? So guys, this is clear. There are 2 independent normal stresses and 1 shear stress. Now guys, come to 3-dimensional stress system. Here how many total? Total, you know, right? Some time back somebody told, right? How many total stresses? Total is 9. How many independent? This is one of the gate question. How many independent stresses for
Sir,
3D? Not 4. It
four
is
or
6.
five.
6 na Anand. How 5? Say you have 3 normal, right? What those normal 3? Sigma xx, sigma yy, and sigma zz. Then you will have independent na sigma xy, sigma y, sigma yz, and then sigma zx. Right? So total how many? Abhirup, very good. 6, right? So total 6 are independent stressors. So guys, this is how we teach. Getting guys essence? It's not like simply write formula and solve some gate question done and tell so many stories, serosiri, all those things we don't do at IGC. This is what our format of teaching, guys. You guys have taken, right, aerodynamic session, right? The previously that aerodynamics, right? So we just believe in teaching, okay, and properly teaching, in-depth teaching. So you understand everything, concepts, and then we solve problems. Clear? Okay. Now, guys, we are well aware of stresses, 2D stress system. Clear? Gopal, this is clear, right? Madan, Dhananjay, Anand, Abhirup, Sindhuja, Nivesh,
Yes, sir.
Saurabh, Vinayaka. Clear na? Now, Anand, this doubt is clear na? Why 6 are independent from
Yes,
9? Yeah, and what is
yes, sir.
3D stress system? What is 2D? Okay, good. Now, guys, you know stresses in what? X and Y direction. Yes or no? Clear? Now suppose I rotate this xy coordinate with some angle theta. I can rotate, right? Yes or no? You can see it is rotated, right? When you rotate this, then I want to know what is my stress in S direction and T direction. How do you find? Anybody know? Anybody have learnt this stress transformation?
Sir,
Or
using trigonometric functions, we can derive, sir.
exactly, in trigonometric form. So we need to use stress transformation, okay, to find stresses on in rotated coordinate, or we also call on stresses on inclined planes. Okay, I will explain. Now suppose you know already stresses in xy direction and it is rotated by some angle theta, and this theta is what? Theta is anti-clockwise. Now guys, I want to know what is my sigma ss, sigma tt, and then corresponding shear is what? Sigma st. Yes, Nived, you are mathematics guy, right? You know transformations well. Okay, so now guys, I will draw this also graphically, how you can see this stress system in inclined form. Okay, so let me see the space. Yeah, here I have a space. So what I will do, initially you have a stress system which is in xy direction. Okay, like this. Now guys, you can rotate this stress element by some angle theta. Okay, this is what theta, and let me use the different color here. So it is what S direction, T direction. So now how you will see your stress element, guys? If you see your stress element will be something like this. Are you guys understanding? Now, what actually sigma SS, sigma TT, and tau ST will be? So you can see you have rotated your plane by some angle theta. On that plane, you can see this is what here in S direction you will have sigma SS, and in this direction it is what sigma TT, and then corresponding shear stresses. Everybody understanding or not? Clear? Now guys, this new stresses on my rotated plane, how we write? We write in this matrix form. When we take classes, we derive also ki how this matrix is formed. Okay, how this matrix is formed. So what is here? C is cos theta, S is sin theta. So if you write, guys, what is your sigma SS? So sigma SS is nothing but what? C square, which means cos square theta sigma XX, then sin square theta sigma YY, then 2cs. 2cs means what? It is 2 cos theta sin theta, which is nothing but sin 2 theta. Then it is what? Sigma xy or tau xy. Is it clear? What this equation? Same way. What is your sigma tt? Sigma tt is nothing but what? It is sin square theta sigma xx plus cos square theta sigma yy plus sin 2 theta tau x, not plus. Here there is a minus sign. It is what? The last term is what? Minus sin 2 theta into sin 2 theta into tau xy. Clear everyone? What is this sigma SS and tau TT means? That is what we need to derive. We need to do transformation using force polygon. Abiru, I will simpler form which I will tell you. You guys learn in your strength of material. Okay, using the triangular element. You know, right? Abiru, have you learned this subject strength of material in your third or fourth semester? So those who are watching this session on YouTube, they can ask if any doubt in chat, right? So this I have done in what? In a rectangular form only. But guys, you all are familiar with what? You all are very much familiar. Now I have written tau tt, sigma tt. Now what about the last term, which is shear, right? So what is shear? You can see, right? Shear means what? Normal stresses I have written, right? Sigma SS and sigma TT. Now what will be your sigma ST? Sigma ST is what? Minus CS sigma XX. So it is what? Minus cos theta sin theta sigma XX plus cos theta sin theta sigma YY plus cos square theta minus sin square theta into sigma xy. Yes or no? You guys can check this from this matrix. Finally, further if you simplify, most of you will be knowing your shear stress on inclined plane is given by what? It is sigma yy minus sigma xx by 2 into sine 2 theta plus sigma xy cos 2 theta. Yes or no? Now, guys, we all are what? We all are very much familiar with what? We all are very much familiar with what? With this. All of you know, right? There is a triangular element and it is making some angle theta from vertical. Okay, and here you already know this is sigma yy and this is what? Sigma xx. Then you have corresponding tau xy or sigma xy. Then they ask what? Unknown stress, this sigma, and then corresponding this tau. Yes or no? Everybody know this, right? Whoever have learned strength of material. Clear? It is not biaxial stress system, Gopal. It's a 2D stress system. I will tell also what biaxial stress system means. But in 2D stress system, guys, we usually in strength of material Indian author, they use this triangular element and they find what? Sigma and tau. Now tell me, guys, this sigma is what? Sigma t or sigma s? This is sigma t or sigma s?
Sigma T, sir.
Sigma t.
Yes, sir.
Why it is sigma t? Think and tell. Is this t direction? You can see the initially okay, let me draw here also this rotated plane.
Yes, sir. Sigma, yes, because it gets aligned with the angle with the new transformation line.
Yes, so now you understood, right, Anand, what it is,
Yes, sir.
right? Now, if you see this is what? S direction, and this is what? T direction, and you can see this angle is what? We have written this angle as theta. Clear, na? So that is what? Sigma s. Now you all understood what people do mistake. They right, they don't understand what is sigma s, what is sigma t, right? And some people write sigma ss, which is what? Which is cos square theta sigma xx plus sine square theta sigma yy, and then sigma xy sine 2 theta. Some people write without knowing what it is. It is sine square theta sigma xx plus cos square theta sigma yy minus sigma xy sine 2 theta. Clear? Now, guys, I will explain. So in this triangular element, right, you can see this angle will be theta, right? So this is nothing but sigma ss. Now, guys, instead of this triangular element, if I write my triangular element like this, so this will be theta angle. So this is your sigma yy, this is sigma xx. Corresponding shear, it will go like this will go. Now what it is? Anybody, what it is? Sigma t or sigma s? What it is? Sigma t or sigma s? Exactly, it is sigma t. Okay, so guys, you can see initially this is a rectangular element, right? And we have made a cut by this inclined plane which is making theta angle from vertical. So you can see guys, this outside triangular element is nothing but this. Okay, now same way we can find this triangular element also, right? How? See, this is your 2D stress system. Instead of, we can cut like this, yes or no? We can cut, right? Okay. So guys, basically how these triangular elements are formed, which are given in your textbook like Ramamrutam, Kurmi, right? Or some other textbook of strength of material. Saurabh, Nived, are you understanding? Dhananjay, Abhirup? Okay. Yeah. So guys, you have to understand this stress transformation well to solve any question related to SAM in GATE exam. Okay, so these are your stresses. This is normal stress which is in S direction, this is in T direction, and you guys understood what sigma TT and what sigma SS mean, and this is what shear. So shear will remain same, either you use this triangular element, this. Now on this, if you see, your corresponding shear will be acting like this. Okay, clear. Now guys, this all okay. Now guys, there can be two cases. There can be two cases. What two cases? One case when you know what guys, you know your stresses in xy plane, and there can be another case where you know your stresses in what? Anybody? You know your stresses in what? S and T direction. But what is unknown? What is unknown? Anybody, what is unknown?
TS and here XY, sir. Or theta
No.
sometimes. They trying
In
to
one
angle.
case, unknown is what? Sigma S and sigma T. And another case, here unknown is what? X and Y. So how the my matrix will be? So the first you can write your matrix is what? Sigma S, sigma T, and sigma ST, right? And one more thing, guys, your normal stress or tensile stress can be written by what? Either sigma SS, or we can write with single suffix also. Both are same. If single suffix means it's always normal stress. So it is what? Sigma S, sigma T, tau st. What it will be? It will be c square s square 2cs s square c square minus 2cs, then minus cs c square minus s square. It is multiplied by what? Sigma x, sigma y, and then sigma xy, right? Because what is unknown here? These are unknown. Now guys, in second case, my sigma s is known, my sigma t is known, my tau st is known. So what is unknown? What is unknown in that case, Gopal? What is unknown? Your unknown is what? Sigma x, sigma y, and then sigma xy. So in that case, what we have to do? We can take inverse of this matrix. If you take inverse of this matrix, it will be simply what? C square s square minus 2cs, it will be s square c square 2cs cs cs c square minus s square. Okay, and this will be what? It will be tau sigma s, sigma t, and sigma st. Clear? So what we can do in this matrix, instead of theta, we can substitute theta as minus theta. Then we will get this matrix. Clear? So you can see here, initially you can see here the theta is making what? This angle is anti-clockwise, right? With respect to what? Given quantity. Now in this case, with respect to given quantity, this angle is what? Clockwise. So that means we have substituted in this matrix, from this matrix theta as what? Minus theta. Okay? Everybody, is it clear what I am talking? Yes or no? Chinduza, is it clear?
Yes, sir.
Okay, so these are your transformation matrix. Okay, so now guys, once you know transformations, the next important part is what? Principal stresses and principal plane. So what are the principal stresses mean, guys? What you guys mean by principal stresses? Anybody? Yeah, so principal planes are those planes on which shear stresses are zero. Or what you can say, see, the initially you already know, if we change theta, what is changing? Stresses are changing, right? Yes or no? If you change theta,
Yes, sir.
stresses are changing. So there will be one theta for which what happening? There will be one angle theta for which your normal stresses are what? Normal stresses are Anand what? Maximum or
Maximum.
minimum? It is maximum also, it's a minimum also. Maximum principal stress is known as what? Major principal stress, and minimum principal stress is known as minor principal stress. Clear? So principal stresses are nothing but those are corresponding to a plane on which either your shear stress, which is what? Tau, or which is nothing but what? Sigma st is 0, or dou by sigma upon dou theta equal to 0. If you use any of these condition, you will get a value of angle theta for which your stress is maximum or minimum. So what is that angle? What is that angle? Principal angle, right? So how you find principal angle? Theta 1. So theta 1, when you substitute your sigma st equal to 0, what it will be? It will be 1 by 2 tan inverse, tan inverse, guys, what? Tan inverse 2 tau xy, right? Tan inverse 2 sigma xy upon what? Sigma xx minus sigma yy. So this is what your principal plane. Then you have two principal plane, right? Theta 1 and theta 2. So we always know, right, what? Theta 2 is always theta 1 plus 90 degree. What I mean, you can see, suppose this is what your principal plane orientation. So you can see this will be one plane, and then perpendicular to that is second plane. So you can see it is theta 1 and then theta 2. So theta 2 is what? Theta 1 plus 90 degree. So now guys, you know the principal plane. Then what is your principal stresses? So my principal stresses, guys, if you write your principal stresses, once you know principal plane, how you write, guys? Your principal stress formula, sigma 1 comma sigma 2. Anybody knows principal stress formula? Yes or no? I am not deriving today, I am just telling. Anybody know principal stress formula? Yes or no?
No, sir.
Okay, no problem. So how actually, Anand, we derive? See, once you know this theta 1, right? So this theta 1, you need to substitute in what? You need to substitute in this sigma ss and sigma tt. So you will get your principal stresses sigma 1 and sigma 2. So that will be coming as what? That will be coming as sigma x plus sigma y by 2 plus minus under root sigma x minus sigma y by 2 square plus sigma xy square. Okay, so these are what your principal stress. Plus means the first principal stress, minus means your second principal stress. Now guys, these principal stresses you can find by alternate method, which is very easy method. What that? You can write your this sigma ij matrix in what? Matrix form. What it is? Sigma xx, sigma xy, then sigma xy, sigma yy. Now guys, if you take the eigenvalue of this matrix, what will be those eigenvalue? Can anybody tell? You know guys, eigenvalues, Mr. Nived, you will be knowing surely, right? So you all know, right, how to find eigenvalues for this matrix? If you write sigma minus lambda I equal to 0. So what is lambdas? Lambdas are your eigenvalues. And these are nothing but what? These lambdas are nothing but what? Anybody? These lambdas are your principal,
Eigenvectors.
yeah,
Principal stress, but they are
stress.
eigenvectors.
Not eigen. Lambdas are eigenvalues. So lambdas are eigenvalues and these are nothing but your principal stresses. Why? Because eigenmatrix, in eigenmatrix we always knows guys what? In eigenmatrix these terms will be zero, right? This is what the property of eigenmatrix, right?
Yes, sir.
Your your I not equal to j terms are always zero, right? So these will be your principal stresses. Okay, so by this method also you can find your principal stresses. Once you know eigenvalues, we can find what? Eigenvectors. So eigenvectors are nothing but what? Your principal plane, which is what? Theta 1 and theta 2. So this is the another or alternate way to solve the problems of principal stresses. Okay, now the next part, once you know the principal stresses, there is something called maximum shear stress or plane of maximum shear stresses. So guys, how to find maxima minima? You already know, right? Tau formula, tau or what? Sigma st formula. What is that? Which is what? Sigma yy minus sigma xx upon 2 into sine 2 theta, right? Plus sigma xy cos 2 theta. Yes or no? We have written, right? Everybody, we have written na shear stress on any inclined plane. Yes or no, Mr. Abiru? So when it will be maximum or minimum? If you differentiate this tau with respect to theta and equate to 0, right, you will get the condition for theta, right, for which it will be maximum or minimum. So that is known as theta 3. And usually what is theta 3? It is minus 1 by 2 tan inverse. It is what? Sigma x minus sigma y by 2 tau xy. Okay, so this is what? Formula for what? Maximum shear stress. This is the formula for what? Maximum shear stress. What it is? 1 minus 1 by 2 tan inverse sigma x minus sigma y upon to tau xy or sigma xy. Clear everyone? Now guys, by substituting theta 3, where you will substitute theta 3 to find tau max? Can anybody tell where this theta 3 will be substituted? Vinayak, Anand.
In the main equation, sir.
In this equation, right? Because
Yes,
this
sir.
equation is in theta form. So if you substitute in this equation theta 3, what will be tau maximum coming? It will be coming as what? Under root of sigma x minus sigma y by 2 square plus tau xy square. Okay, so this is what formula of tau max. Okay, so this is how guys we find maximum shear stress, and this is what plane of maximum shear stress. So there are gate question guys related to this. Now somebody was telling guys, right, something called, yeah, one more thing. Once you know this maximum shear stress, on that plane, what is corresponding normal stress? So on plane of maximum shear stress, suppose you are initially guys, this is what xy plane, okay, and we are getting angle theta 3, okay. Now you guys know what was theta 3, plus or minus? Theta 3 is what, plus or minus? Minus, right? So how I will write angle, clockwise or anti-clockwise? We are getting negative value, so how we will draw, Gopal, angle?
Clockwise.
Clockwise, right? Because when theta is positive, then it has to be anti-clockwise. So theta we got negative, right? So that means now my plane of maximum shear will be how it will be? It will be like this, okay, and this is theta. Now guys, you have to draw corresponding stresses, right? So you can see here there is a normal stress, suppose this is sigma, okay. So my corresponding shear will be tau max. So here you can see this is tau max, and this will be also sigma. We guys know on plane of maximum shear, on plane of maximum shear, your both normal stresses will be of same magnitude. Okay, so suppose the my normal stresses are sigma. So what it will be? You are both normal stresses, right? You can write sigma 1 is what, sigma, and your sigma 2 is what, also sigma. Okay, how I found this? This is again guys, what anybody can tell? Have you guys learnt about Mohr circle?
Yes, sir.
Yeah,
Complex
in
analysis.
Mohr circle you can see on both the plane where you have tau max, your corresponding normal stress is same, sigma, and this sigma is given by what? It will be sigma x plus sigma y by 2. So center of Mohr circle guys, we all know it is given by what? Sigma x plus sigma y by 2 comma 0. So this is what normal stress on the plane of maximum shear. Are you guys understanding what I am talking? Yes or no? This is theta 3.
Yes, sir.
Okay, yeah. So this is how we learn about we learn about maximum shear stresses and other stuffs. Okay, now guys we will solve some yeah, somebody was talking about biaxial stress system, right? Yes or no? So guys, biaxial stress system is what? A special case of 2D stress system. So first we discuss uniaxial stress system. Uniaxial stress system means what? You have suppose only sigma xx, means your sigma yy and your tau xy are 0. Or you can have, guys, another case where you have only what sigma yy. Then what will happen? Your sigma xx and tau xy or sigma xy are 0. So this is what uniaxial. Now, guys, in case of uniaxial stress, we can still write what your values, guys, right? Stresses on inclined plane. So what will be your sigma ss? What will be your sigma tt? What will be your sigma st? So you all know, right? We have sigma xx alone. So it is what sigma xx c square, which is what cos square theta. Then sigma tau sigma tt will be what? It will be sigma xx sine square theta, and it will be what? Minus cos theta sine theta sigma xx. So these are what stresses on inclined plane in case of uniaxial stress system or uniaxial loading. What will be your principal stresses in case of uniaxial? Anybody? What will be your principal stresses? Sigma 1 will be sigma xx, sigma 2 will be 0. What will be your principal plane? Theta 1 will be 0 and theta 2 will be 90 degree. Okay? What will be the maximum shear stress? So my maximum tau maximum will be sigma xx by 2. What will be your theta 3? Anybody tell? What will be theta 3? Plus or minus? Plus 45 or minus 45?
Minus 45.
Exactly, very good. It will be minus 45. Okay, so this is how we write this special case of uniaxial loading. Same way, you can have a biaxial stress system. So in case of biaxial stress system, what is zero? What is zero? Anybody? What is zero in biaxial stress system? If you write from 2D to biaxial stress system, what is zero? Saurabh, quickly, what is zero? Hmm? Nived, what is zero for biaxial stress system? See, initially, if you write 2D stress system, I'll just draw and tell me by comparison. Your 2D stress system is what? You have sigma xx, then you have corresponding shear, you have sigma yy. So, what is zero? If you compare 2D and this biaxial stress system, what is zero? Vinayak? Yes, Gopal. Shear stress is zero. Very good.
Shear stress.
Somebody was writing na initially biaxial stress. Who was writing that, guy? I don't remember. Okay. So now you understand, Gopal. What is actual biaxial stress system? Clear? Because in case of biaxial stress system, your shear stress, your sigma xy, or you can say tau xy is what? Zero. Right? Now, in this case, what will be your stresses on inclined plane? Sigma ss will be what? It will be cos square theta sigma xx plus sin square theta sigma yy. What will be your sigma tt? It will be sin square theta sigma xx plus cos square theta sigma yy. What will be your tau st or sigma st? It will be minus cos theta sin theta sigma xx plus cos theta sin theta sigma yy. Or you can write it as what? You can write it as what? Sigma yy minus sigma xx by 2 into sin 2 theta. Clear? Is it clear? Everyone, is it clear? Yes or no? Quickly. Okay, so this is how I can write my stresses on inclined plane for biaxial stress system. Now guys, what will be your principal stresses for biaxial stress system? You can see there is no shear, right? So what is your principal plane? In this case, what is principal plane if there is no shear? Theta 1. Anybody? What will be theta 1? Anand.
Zero, sir.
Exactly. It is what? 0. Right? What will be theta 2? It will be
90 degrees.
0 plus 90, 90 degree, right? So we already know my principal plane, right? So what will be your principal stresses there? Sigma 1 will be equal to sigma xx, and what will be your sigma 2? Your sigma 2 will be sigma yy. What is your principal plane? Theta 1 is 0, theta 2 is what? 90 degree. Clear? Now maximum shear stress. So in case of basic elasticity, what will be not basic elasticity, sorry, biaxial stress system? What will be your tau max? Anybody? Mr. Gopal, what will be tau max? It will be sigma xx minus sigma yy by 2. Very good. What will be your theta 1, theta 3? What will be theta 3? It will be plus minus
Both,
45
both.
degree.
Plus and minus, sir. Both.
It can be, depends on what? Magnitude of sigma xx on sigma yy. Okay. Suppose my sigma xx is greater than sigma yy, then tell me it will be plus or minus theta 3. Hmm? Plus or minus? Why, Gopal? If sigma xx is greater than sigma yy, the angle will be minus 45 degree. Why minus 45 degree? Because we know what is theta 3. It is minus 1 by 2 tan inverse sigma x minus sigma y upon 2 tau xy. Now tell me, it is coming plus or minus?
Minus, sir.
Exactly. So we have to be very careful about orientation. Okay. So these all are important thing. Now the last case is what? Pure shear case. So how is class, guys? Are you guys finding it interesting? Enjoying?
Yes, sir.
So is it different from what you guys have learnt in your college?
Yes, sir.
Okay, good. So now the last case is what? Pure shear, right? So in pure shear, guys, what is the speciality of pure shear case? Anybody? Sindhuja, what
They
is
both
the
have same magnitude.
what's a
They
magnitude? Use check and tell.
like
In pure
like
shear case,
force.
huh?
No normal stress. Only the magnitude of XY plane acting, sir. That's all.
Not what XY plane. See, you have in case of pure shear only shear stress. Okay, there is no normal stress. So means your sigma xx and sigma yy are 0. Okay, and guys, pure shear case is what? You know, torsion of shaft, right? So torsion of shaft is what? Case of pure shear. So you can see there is only tau xy. Now guys, you have only tau xy, and I am taking one rotated element, guys, which is at some angle theta. Now tell me, guys, in this new rotated element will be there normal stress or not? What I mean, will there be sigma ss, sigma tt or not? Anybody? Will there be sigma SS or sigma TT or not? Yes or no, guys? Quickly. No, no, you are wrong. So, guys, you have to understand this properly. Even it is a case of pure shear. If you see your transformation matrix, what will be your sigma SS? Your sigma SS will be 2CS, 2CS tau xy or sigma xy. What will be your sigma tt? It will be minus 2cs tau xy. What will be your sigma st? It will be cos square theta into tau xy. So this is nothing but what? Sine 2 theta, sine 2 theta tau xy, and this is what? Minus sine 2 theta tau xy, and this is what? The last one, cos square theta tau xy. So are you guys understanding this point? In case of pure shear also, if you rotate your stress element, you will have non-zero normal stresses in different orientation. Clear? Is this making sense, or are you guys getting clear? Everybody, yes or no? Please respond. Okay, so once you know this, these all, the next is what? Principal stresses. Because GATE 2024 question is from what, guys? Pure shear stress case. Now, in case of pure shear stress, what will be your principal plan? Can anybody tell Gopal what will be your principal plan? Theta 1. How you find theta 1? It is 1 by 2 tan inverse 2 tau xy upon sigma x minus sigma y. Now you tell me, I for pure shear case, what will be theta 1? I have given everything. We know for pure shear case, sigma x is 0, sigma y is 0. So what will be theta 1?
45 degrees, sir.
Exactly. So you know, in case of pure shear, your theta 1 will be 45 degree, and theta 2 will be what? 145 degree, 135 degree. Okay, 45 degree and 135 degree. Clear? Now, guys, what will be corresponding principal stresses? Anybody can tell? In case of pure shear, what will be your sigma 1 comma sigma 2? You know the formula, right? What it is? Sigma x plus sigma y by 2 plus minus under root sigma x minus sigma y by 2 whole square plus tau xy square. From here, what we find? What will be your principal stresses? Anybody? What will be your principal stresses? Those will be, if you substitute sigma x, sigma y 0, you will get plus minus tau xy. Okay? And if you find theta 3, your plane of maximum shear stress, theta 3 will come as what? 0. So what will be your tau max? In case of pure shear, it will be nothing but tau xy. Okay? Are you guys clear about this? Yes or no? Okay, so now let's see directly GATE 2024 question. Okay, so This is one of the question from Gate Mechanical. Okay, you guys read this question. Yeah, so this one of the question we can solve. Yeah, so read this question and then tell me the answer. Given at a point, the state of stress is combination of case 1 and case 2. Okay, now you can see your case 1 where they have mentioned sigma x1 value and it angle is what 45 degree. It is what tensile nature. Okay, it's a tensile nature. If you take the example case 2 where they have given what sigma y value. Okay, sigma y1 value, but it is what compressive nature. So what you are finding, the orientation theta is 45 degree and your sigma x1 is what 10 and sigma y1 is what minus 10. Now there is no shear, right? So what it mean in this case 1 and case 2 there is no shear? What it mean, Anand?
Sir, biaxial example.
Biaxial example. And what this sigma x1 and sigma y1?
Sir, this one second, sir. Principal stresses and principal
Exactly.
strain.
These are principal stresses, right? Clear, everyone? So this sigma x1 is nothing but your sigma 1 and sigma y1 is nothing but sigma 2. Now what is asked in question? Read the question, guys. Find the sum of maximum principal stress and minimum principal stress at that point. So what it will be? It is sigma 1 plus sigma 2. So what it is, guys? Sigma x1 plus sigma y1, right? So now tell me what is the answer. What is the answer, guys? It is 0. Clear? So this is how we need to solve gate question. Okay, you should know exactly what is given in question. Now if you look this question, read the question what it says. The state of stress at a point on an element is shown in the figure A. The same state of stress is shown in, just a moment guys, just a moment.